Welcome to the machine learning world of Liferay DXP. This is the agenda for today. Well, let's start. Filipe and I are Liferay consultants, and as a part of our job, we have to help customers build whatever they want to build by using Liferay DXP. And in the last months, we're hearing always more and more the words machine learning. Basically, what some customers want to do is by using their existing data, give the best possible experience to their customers. If you have read a little bit about machine learning or you have studied, probably all these algorithms are familiar to you. But if not, don't worry, because what we're going to talk about today is about the group of things, the group of problems that we can solve, that we can easily solve in Liferay DXP by using machine learning. And the first problem group is classifying. If I have, for example, pictures of oranges and pictures of apples, and then I run a machine learning trained model over my set of images, I would put the oranges in the orange category and the apples in the apples category. So I could do that with content, I could do that with documents, I could do that with users, and I could even raise an alert, for example, when a user posts a blog, a comment that is likely to be spam. So that I could, for example, take that comment, redirect it through a workflow, and have it approved by a person, or let it go through if it's not classified as possible spam. Then we have another group of algorithms called grouping or clustering. In this case, I don't know what oranges and apples are. I don't have any information about my system. The only thing I know is that I have 1 million users in my system. They all have the same, they're all under the same group or the same role or whatever. And I just run a clustering algorithm that doesn't need to be trained. And what it does is it groups my users into clusters. So I have cluster A, cluster B, and cluster C. And what that is giving me is information about the system. Now I know that I have 3 very distinguishable groups of users, and I can use that information to classify things manually myself. So that group of that technique is giving me information about my system when I don't know anything. Then another thing that I could do with machine learning is trying to guess try to predict a user's behavior, try to guess what a user will like, and for that we have an example of a recommender engine. I forgot to say that Filipe has an example of a classifier, which is the first group that we mentioned. And then, at last but not least, we have natural language processing, that this could be related to machine learning, probably is not machine learning, it doesn't matter. It is something that will be a very good fit for Liferay. We're not going to talk about it because it's probably the most complex of all these groups, but at least the 3 first ones are a very, very easy fit for Liferay. And we're going to show it now. So let's see the first use case. And the mouse doesn't work. Okay. Let me, here. Wait. Here, perfect. Okay, thank you very much. So this is basically a brand new Liferay. It has a few things. It has some content, but it doesn't have users. So I'm leveraging on Liferay remote services by to create the users through a shell script. So I run the shell script that leverages on these Liferay remote services. I refresh the page and I have a bunch of users created, and now I'm going to impersonate the first user. There is no trace of behavior of that user in the system. That user is Filipe Afonso. He's here and he likes ping pong. So he starts reading ping pong articles. So he reads the first article and he reads a second ping pong article. And if you look on the top, that recommender client portlet, that's a portlet, a really ugly portlet, that what should have is recommendations about recommendations for Filipe. But because we don't have enough data in our system, Filipe doesn't get any recommendation. But let's continue. Now we're going to log in as a second user, and this user is John Finney. He likes ping pong as well. You see that there is no trace in the system of this user. There is no behavior saved in the database. He has to accept the terms of usage. So he logs in. And then when he logs in, we see that, like Filipe, he doesn't have any recommendation yet. So he reads the first ping pong article. He goes back, and let's see what happened. You see there, we get a recommendation of a blog article talking about ping pong, how to improve your spins. So John clicks on that article, goes back, and he doesn't have any recommendation anymore because we cannot recommend him anything that he hasn't read. And then, let's continue, and then Filipe reads a journal article John reads an article that Filipe hasn't read, and then John closes the session, and Filipe refreshes the page, and he has that recommendation of the journal article that John read that he didn't. So let's continue. How does this work underneath? So if this problem would be similar to this, what we have here. We want to guess if this user here likes Apple or not. And we want to base that guess upon the other users' preferences. So we have 2 users that don't like Apple and 2 users that like Apple. So what do you think we should recommend him? Or what do you think he likes Apple? If we look a little bit more in detail in the data, we will see that the second and the fourth user are closer. They have a more similar behavior or a more similar preferences to the user we want to give a recommendation for than the other users. In fact, the first user doesn't have anything to do with our user. So these 2 users will have much more weight. These users' preferences will have more weight when we want to give a recommendation for this user. So our guess is that he's not going to like Apple. When we want to build a recommendation system like this, we need 3 things. We need a similarity function, which is what tells us how similar 2 users are, and that will return a score. And that score, the higher the score is, the more similar to each other users are. Then we need an algorithm that compares all users with all users. By using that function, we will pass that function as a parameter. And then, of course, we need the data. And where do we get the data from? We have it in our database, and we will expose it through a service that we built with our service builder. Previously, we have installed the audience targeting plugin, and the audience targeting plugin saves in 2 tables all the pages that users have visited and all the content that users have opened. So we expose it to the service, and that's what we have. So we just need 3 things. And let's talk about distance functions. If we want to measure the distance between 2 users' behaviors, if every characteristic that makes a user unique is a dimension in a Euclidean space, probably the most intuitive similarity function would be the distance between these 2 points in the Euclidean space. But there are other functions. There are, for example, the Cousin and the Pearson similarity scores that are good for problems where you have to star products. If you like a product very much, you give 5 stars, and if you don't like it at all, you give 1 star. I'm not going to get deeper into that. Just if you're interested, just Google these similarity functions. We have other functions like for binary problems, like our problem. You either visit the page or not, which means you like it or not. And the picture speaks by itself. It's not necessary to explain anything. And this function that you see here is what we have implemented. You remember the example? Filipe, we have Filipe and John. And if A is a set of content that Filipe has seen, and B is the set of content that John has seen, we get the intersection, and the larger the intersection, the more they have in common. We would just have to normalize that intersection by the size of A plus B, not to favor the larger sets, and that's our distance function. It's called the Jacquard function. As you see, this is not Java, it's Scala. Why did I do it in Scala? Because, well, Liferay is not only tool agnostic, it's also language agnostic. Anything that compiles into Java bytecode and anything that can be put into a jar file and deployed into an OSGI component is Liferay compatible. It could be Scala, it could be Clojure, whatever you want. And this is the algorithm itself. As you see, half of the screen is comments, and this is what it does. And I'm going to explain what it does in a very graphical way. This is a very similar problem. Just suppose that these are Windows, Android, Apple, and Ubuntu are content that I want to visit, and I want to give recommendations for this guy here. So the first thing, I see what he has in common with the other users. I calculate the similarity score. The two first users are the most similar to our user. Then I, of course, ignore the pages that my user has seen. And then I multiply the numbers that I had that there were always ones, because it's either one or nothing, by the similarity function. And then at the end, I will just add the columns, and the result will be given in this row. How do you interpret this result? We would interpret it this way. If we only had to recommend one thing to this user, we would recommend him Ubuntu. If we had to recommend him two things, we would recommend him Ubuntu and Android. And pretty much that's how a recommender works. Well, there are many types of recommenders. This is a collaborative filtering recommender, a user-based collaborative filtering recommender. But we have content-based or hybrid recommenders. And what else could I say? I could say that once we have the distance function, other ideas that you can, where you can use it is, if we have, if we sort the most similar users to me, I could recommend myself to follow another user that is very similar to me, or to be friends with him in a social network in Liferay DXP. And then another thing to consider is item-based versus user-based collaborative filtering algorithms. R is user-based because it compares users with users. But if we switch it around and we put the users on top as rows and the items as columns, you know, we switch it all over, and we apply the same algorithm, we would just have the item-based algorithm that compares items with items. This has an advantage that has the advantage that if two items are similar now, over time they will still be similar. A user can change his behavior, but items won't change their behavior because they don't have behavior. And well, just to summarize, I'll say three things. The recommender is very simple. You could do it yourselves. It's a few lines of Scala. If you do it in Java, it's a few more, but it's still very, very feasible. Then you need a portlet to show the results, what you want to recommend to the users, and just a service that you can build with a service builder to expose the user's data, behavior. And you have the code there in GitHub. Well, I don't know if I have time. Yeah, okay. So just this is a toy kind of recommendation engine. But we're going to try it in an experimental platform called Grow. That there is a team in Hungary, and we're going to try to put it there and see what happened and how it behaves, and we will probably evolve it. But like that's the way probably you should, like, if you shouldn't be scared of these things. You just you could try the same code, start your recommendation engine, and then it will work right away. You've seen it works, and then start improving it. If you have 1,000 users and then it starts going slow, you modify things to make it faster, and that's, I think, the way we should go. And now Filipe is going to give a better example, very impressive, that I'm sure you're going to like.
Thank you, Carlos. So, hello everyone. Let's continue here with this amazing journey over this world of machine learning, working together with Liferay DXP. Right? So let's go to our second example, our second use case, which is image recognition. Right? So this is our problem, right? And as you can see there, it can be a really tough problem, even for us humans, right? That's image recognition. Is that a muffin or is that a chihuahua? Right? So this is the context, right? So imagine that you have a Liferay DXP installation, a server up and running. It can be an e-commerce solution, for example, or a retail company. And you have loads of images in there. As of today, if you want to categorize those images, you need to do that manually for all of them, right? Now, question is, do we have a better way to do that? Well, we believe that we have, of course. And so what do we know today? We know that machine learning can do automatic image recognition for us, right? We also know that Liferay DXP is a fantastic integration tool, and really easy to extend and customize. Especially now with OSGI framework, it's even easier to, to add your own code as a module and deploy that in Liferay DXP. So with that in mind, we have some options we need to consider before implementing these use cases or these examples or these kind of features. So first option could be to implement your own neural network, for example, engine or module to do image recognition for you. Well, problem with this is that it requires some effort, right? Because you need a neural network trained to do that for you. Second option could be to use an external service, right? So it's much easier the effort is much less, so much faster to achieve results. Problem is that then you will have a dependency for that external service. And also you need to be aware of the free layer, because usually you can do X amount of requests. From that moment on, you start to pay for each request to the service. On Liferay DXP side, you also have some options to consider. So where do you want to customize it? Where do you want to extend it? Is it like a background process running and categorizing all the images for you? Is after each upload? It could be a custom application as well. And it can also be a mobile app. For example, using Liferay screens, you can have a native app to do that for you. So with that in mind, the selected approach to implement this use case was to use an external service. In this case, it was Clarify, so you have the link there. And main reason for that was because it's much easier and much faster, right? The effort to achieve this is much less. On the DXP side was to use a model listener. It was more or less the natural choice, as it is really easy to implement, and it will be applied to all uploads. So after uploading an image, it will be applied. And also it has a benefit that it can also work in your devices through Liferay Sync, right? So just to give some context about these technologies, so talking about Clarify, so they use a deep neural network, right? And they have a bunch of models that you can use according to your context. So for example, if you know that you are categorizing food images, you can use a specific model for that was already trained for that specific context, right? And the idea is really simple. So you have an input, so an image. The model is going to analyze that, and it will give you predictions. So that will be your output. So on the XP side, I'm pretty sure everyone here already knows what is a model listener. Just to give a few words about it. So it will listen for persistence events on models or entities, right? It can be create, remove, update, and it will trigger an action as a response to that, and can be executed before or after the event. So you can find really good documentation about that in devliferay.com, and I would also recommend you to go to Liferay Blade Samples. It's a really good source of information regarding how to build plugins for Liferay DXP. So let's see an example of this. Let's see if I can find the mouse. Where is that? No, I can't. Here we go. So, as you can see there, I have a Liferay DXP bundle, a vanilla one. So if we go now to our documents and media, you will get to see that it's completely empty, right? So let's start by uploading 3 images. So drag and drop it, and they will be uploaded. There you go. So the first one is a pastel de nata, second one is a car, and the third one is a ball in the field, right? So they were uploaded. Let's see what just happened here. If you go to the first one, you get to see that it was automatically categorized for you as no person, sweet, breakfast, food, delicious, sugar, and so on, right? So kind of cool. Let's see the second one. So it is a car, right? A car, vehicle, is fast. So as you can see, it seems to be working more or less, right? So let's see the last image. And it was categorized as soccer, football, ball. We have also there ground, playground, and so on. So it's categorizing not only the main object, but also the environment, right? So as I said before, we can also use these on your mobile devices, right? So let's see an example of that. So here we have Liferay Sync. And you can use this so using your camera, you can take pictures of things and upload that to your server. By the way, this is our office in Dublin. So let's see what we can find to take a picture. So there you go. We have this young man here. Let's take a picture and let's see how this works. Right, so now we are uploading the image to the server. It should be really fast, especially because I take that out of the video. There you go. Let's see if we can find something else to try it out. Let's see. Oh, we have Ray there. Let's take a picture of Ray as well. And let's see what Clarify has to say about it. Again, taking the picture, uploading it to the server, and it will be really fast. There you go. So if you go back now to our Liferay DXP, we just get to refresh this page and you'll see our new 2 pictures there. If you go to the first one, let's see what it says about Carlos. So Carlos is one adult, people, indoors, man. You can see their sofa as well. So again, categorizing everything on all the objects, the main objects in the picture. And finally, about Ray, it says, it's business, no person, and it's cute. So, well, just to show how this was done, first thing, let's just check that it's running and that it is a module. So we can use Google Shell for that. So if you do telnet localhost 311, LB, you see all the modules that are running on the DXP installation. And the last one is image recognition. So it's up and running. Right? So if you want to try this example by yourselves, first thing to do is to go to Clarify and to create an account for you. So, right? So it's a really straightforward process. You just go there, create an account, fill in your data. Then you need to create a project. You select a few options in there, and you'll get an API key, which you will need later in your code to build a client and to get access to the service. Right? That's the key you need to use then. So having this, we go to our code. So this is our DXP workspace. In this workspace, we only have one module. And let's start by exploring the configuration files. So first, the build Gradle file. So the outstanding thing to point out here is that we have that dependency for Clarify API, of course, because you need to get access to the service. And then if we go to our BND file, we don't have anything special in there. Just to show you, it's the default stuff in there. Right? So then basically this module has 2 classes. One is a wrapper for all the communication with Clarify, and the other one is the model listener. So let's start with the Clarify one. First, we build the client I was talking about before using the API key. So we build the client. And the other one is using, is invoking your service, right, for categorization, to categorize your image. So basically, you choose the model that you want to use, you pass your image, and you receive your predictions. Pretty easy. So if we go now to our model listener, to the other class we have here, as we'll see, so it's pretty much a straightforward model listener for the XP. So it's listening to asset entries, as you can see there. Yeah. And what we want to do is to trigger an action after uploading an image, right? So we are after create an asset entry, we are going to trigger this action. But we only want to do this action if it is a file entry. So we are filtering that as well. There you go. And then what we are doing is pretty much straightforward. So what we do is we grab the file from the repository, right? And we pass it, so we are doing that there. And then we pass it to Clarify to be categorized. Right? So important to say is, so when you get to your predictions, all the predictions will have attached a probability, right? So and we are using a threshold, I think it's 95% in here, just to ensure quality of your categorization, right? So finally, what we do is we iterate over all your predictions and we assign that as categories, and that's it, right? There you go. So, and that was the example. So just to give a few words about other approaches and improvements that you can do regarding this use case. So for example, you have other available players in the market that you can try out. For this, we used Clarify, which I can tell you, it was really straightforward, really easy to use. You also have Google Vision or Amazon Recognition, you can try out. Then for me, honestly, the next logical step for this use case is to implement our own neural network, right? And if that is something that you think that you want to take a look on, you can try TensorFlow. TensorFlow is a project from Google, and they have an image-to-text module in there, right? You can find the link there. You have all documentation, really good documentation and source code as well. So it's based on a neural network called Inception, which is already trained. It already knows how to categorize images. It just doesn't know which name to give to those images. So you need to do that final training to that neural network. But it's really interesting. So just to say that if you so this is only like the first step. The options you have are are huge. I mean, for example, imagine that you are on a trip, you are taking photos of your receipts, then you want to upload your receipts to your server. They will be categorized as receipts, can be moved for a specific folder, for example. So it will help you to organize your documents and media. And then maybe you have a workflow configured for that folder, and it can trigger a business process. So it's just an example, right? So, and that was it, guys. So just to share with you some conclusions and takeaways really fast. So I think this proves that machine learning can be really easy to use, right? It's here, it's the present, it's not something in the cloud really abstract. It's here today. And you can use it to solve really complex problems. And with that in mind, Liferay DXP can be a fantastic environment, to do all these experiences and proof of concepts. And also important to say that examples like this will give you improved user experience. So examples like the recommender that Carlos was talking about will give you personalization for your users. And in the end of the day, you will achieve enhanced engagement, right? That's really important. So important to say also is that, so this that we have been talking about here is not the official approach for Liferay DXP, right? Regarding machine learning. So if you want to know more about that, don't miss the future of Liferay DXP keynote that will be like later this evening. So conclusions and takeaways, really fast. Again, Liferay DXP is a great integration tool, really easy to extend and customize. You don't need to be an expert to use machine learning, right? So our key message today, I think it is that go home, have fantastic ideas, and implement amazing modules using machine learning and DXP working together. Thank you so much, guys. And if you have any questions or if you want to exchange some ideas, those are our email addresses. And thank you so much.